Hey everybody, what we're going to be looking at in this lesson is what is known as figuring out the determinant of a square matrix, and we are going to be doing it without a calculator. Now, the determinant of a square matrix, again, going back to previous lesson, is really just a number. And what we do with it is we need to know what the determinant of a matrix is in order to figure out what its inverse is. You cannot figure out the inverse of a matrix without first knowing what its determinant is. Now, the way that we figured out the determinant of a 2 by 2 matrix was uh, looking here. Now, real quick before we get into it, this should be in parentheses where we say the determinant of whatever our matrix is. But we could also put determinants in the form of a matrix, but we're really not going to be doing that. We want to know what is the individual number that we have. So we don't really need to look at that one too much. We really need to look at this where we're going to say the determinant of some matrix is equal to, I don't know, some number, whatever it is. Now, we've already seen how you get the determinant of a 2 by 2 matrix, where we're going to take the, basically we're going to take the diagonals, multiply them together, and then take the difference of them. So one diagonal, A times D, and the other diagonal, B times C, we're going to multiply those values together and then take the difference of them, and that's how we get the determinant of a 2 by 2 matrix. Now, again, that we have to have that number. If we wanted to know what the inverse of it is, we would have to know what is that number. So here we have a matrix. So let's call this matrix B, just for something. And I don't know why this presentation doesn't have brackets on it. Why it only has vertical bars, but you get the idea. So the 7 is in the A position, the 1 is in the B position, 2 is C, and 3 is D. So if we want to know what the determinant of this matrix is, we multiply those together and find out what their number is when we simplify it. So this is A times D minus B times C. And so 7 times 3 is 21, 2 times 1 is 2, so 21 minus 2 is 19. So the determinant of matrix B, so the notation that we would have here, the determinant of B would be 19. And so let's take another example. So here's another 2 by 2 matrix. We have 3, 4, negative 1, and 2. So again, the diagonals 3 and 2 get multiplied together, and the diagonals 4 and the negative 1 get multiplied together. And so, well, 3 times 2 is 6, and negative 1 times negative 1 is positive 1. 1 times 4 is 8. So 6, not 8. 1 times 4 is 4, so 6 plus 4 is 10. I don't know what I'm thinking. So again, let's just call this matrix D, or just something. So I'd say the determinant of D, in this case, is 10. Boy, my board, my cameras are really missing that bottom right corner of my board sometimes. All right, so here, at this point, what I would like you to do is write down the 4 matrices that you see here and figure out what each determinant is. So pause the video for as long as it takes you to do that, and when you're done, restart the video so you can see what the solutions are, okay? So pause the video now, and I'm going to assume that you've done what I've asked you to do and figured out the determinants of these 4 matrices. So here they are. Now again, real quick, we're saying, I don't know why I keep wanting to write D first for some reason when I do this stuff. So A times D minus B times C in this case is going to be 6 times 3 minus 2 times 0, and that's where the 18 and the 0 come from, and 18 minus 0 is 18. So again, just for the next one more example, I'll give you a little bit more detail on negative 1 times the 5, the diagonal is going down, multiplied by the minus the 4 times the 2, the diagonal is going up. Well, negative 1 times 5 is negative 5. Negative 4 times 2 is negative 8. Negative 5 minus 8, negative 13. So there are the determinants of these four. So we're going to take a look at a little bit more. So here are four more matrices. And again, I'm going to ask you to write them down in your notes and attempt to find the four determinants. So at this point, after you have the matrices copied down, pause the video and try to figure out the four determinants on your own. And when you're done, restart the video and see how you did. So pause the video now. And I'm going to assume that you've done what I asked you to do, hopefully. And here are the solutions. So taking the diagonals multiplied together, 1/2 times 6 is 3. 3 times 2 is 6. So that's where the 3 minus the 6 comes from, the various determinants. So if you have questions about how these are the answers or why these are the answers, please make sure you write down your questions or thoughts or whatever, so that way when you come to tutoring or see me in class, you have your thoughts written down. You don't have to try and remember what you were thinking. So now let's take a look at something else. Now, what we're going to look at here is a concept in matrices known as minors, meaning that we're going to be taking part of a big matrix and doing something with it where that smaller part is called a minor. So here what we're going to do is I'm going to show you how you figure out the minor of a matrix. Now the reason why we call it a minor, again, is because we're taking some part of it and doing something with it, and because that part is smaller than the whole thing, that's why it's called a minor. But pardon me, we're actually going to be doing this with four different numbers. The 1, the 2, and the 3 of the first row, and it's hard to tell, but that 5 in the middle of the second row is purple, it's not black. So we're going to be figuring out what are the minors of those numbers of the matrix. Now the way that we're going to do this, and at this point again you may want to pause the video and just get yourself two small straight lines, maybe a pen and a pencil that you can put down, or even if it's just a strip of paper that you can kind of cover up some rows and columns with, that'll be helpful. So you can kind of see how we determine what the matrix of something is. So if you need to pause the video, get that stuff, and when you're done, come back. So the first thing we're going to do is say, okay, well, I want to know what is the minor of element in row 1, column 1, which is a 1. All right. Now what we're going to do, this is what we wind up with. Now let me demonstrate where that comes from. I'm going to, on the board, draw a line. Now on your paper, I wouldn't really draw a line through it unless you want to rewrite the matrix every single time you do this. Okay, so that's why I said you might want to just have a pencil or a piece of paper, or maybe even a piece of dry spaghetti or something, so that you can do this. Well, what I'm going to do is I'm going to draw a line in the row that contains the 1, which happens to be row 1. And I'm also going to draw a line through the column that contains that number 1. And as a result, what's left over that doesn't have anything crossed out is the 5, the 6, the 8, and the 9. Well, the 5, the 6, and the 8, and the 9, this is a minor matrix. And if I find the determinant of that minor matrix, I get a 3, negative 3 in this case, because kind of what I'm looking at is, 5 times 9 minus 6 times 8. Well, 45 minus 48 is a negative 3. So that's where that number negative 3 comes from. So the negative 3 is actually the minor element of element 1. All right. So because that number 3 kind of came from where the 1 is sitting, I would put, I could actually create something called a matrix of minors, and I could put that number 3 in the same place where the 1 is, because that's the number that we used to get that 3 in the first place. Okay, so this is the negative 3 itself is a minor, and I could use those minor elements to create a new matrix, which would be called a matrix of minors. Okay. Well, we'll fill this out a little bit more, and we're not actually going to do anything with the matrix of minors. I'm just saying this is what it would, we could make it this way. Now, if we had to figure out the inverse of a 3 by 3 matrix by hand, a matrix of minors is essential, as long as it's same as with its determinant. But let's go ahead and continue here. So the next thing, and let me go ahead and clear this out. The next thing that we're going to do is find the minor of the number 2. Well, the minor of the 2, I'm going to do the same thing. I'm going to put a line through the row that contains that number, and I'm going to put a line through the column that contains that number, and whatever's left over, in this case the 4, the 6, the 7, and the 9, that produces a minor matrix. So if I find the determinant of that, meaning the 4 times 9 minus the 6 times the 7, well, 36 minus 42 is a -6. So that is where that's the minor of the 2. And we'll kind of do the same thing with the 3. So again, take your spaghetti strands or string or paper or whatever that you got, maybe just a pen and pencil or even your fingers. I would kind of do the same thing. The 3, I'm going to put a line wherever the 3 is. In this case, it still is the first row. I'm going to put a line through the same column that contains that number, and what's left over produces its minor matrix. So in this case, 4, 5, 7, and 8. And again, if I do and I forgot to put the 6 here, so this would be a 6. And then the -3 that I got here, that would put a -3 in my new matrix of minors if I were going to create the whole thing. And the last one that we're kind of looking at is the 5. Well, the 5 in the middle, I'm going to put again a line through the row that contains that number and a line through the column that contains that number, and whatever is left over, that's what produces the minor matrix. So in this case, the 1, the 3, the 7, and the 9. And if I find the determinant of that, I get a -12, which would go right there in the matrix I would be producing. But again, we're not going to do it for all 9 numbers, but we could. And if we were figuring out, and if we had to calculate the inverse of a 3 by 3 matrix by hand, we would have to finish filling out that matrix of minors and do it for all 9 numbers of the original matrix that we were given. So that's what we would refer. Now, the reason why we're doing this is because this is a way that we can figure out the determinant of a 3 by 3 matrix, which is necessary. Regardless of whether we're finding the inverse or not, we're going to be asked to do that. And obviously, it is capable of producing something known as a matrix of minors, which also is a necessary element when we figure out the inverse of a 3 by 3 matrix by hand. Now let's look at the determinant. Now here I'm going to show you 2 methods to figure out the determinant of a 3 by 3 method, or 3 by 3 matrix. The first thing that I'm going to show you is using the minors. Okay. What we just did, I'm going to show you how we can use the minors to figure out the determinant here, but I'm also going to show you another method that's more related to how we find the determinant of a 2 by 2 matrix, but I'll show you that here. I'll explain that a little bit further here when we get to it. Now, when I have a 3 by 3 matrix, I can find the determinant using any row or any column. It doesn't make any difference whatsoever. So what I would do is I would take whatever numbers are in that row or column and multiply that number by their particular minors. And when we're done, we wind up with the determinant. Now, here where it says apply the plus minus thing to be explained, well, I'm going to explain that to you now. Whenever we're figuring out the determinant of a 3 by 3 matrix, we wind up looking at an array of numbers. So because it's a 3 by 3 matrix, this array that I'm going to kind of be looking at is also going to be 3 by 3, where starting at the top row, going left to right, filling it in, going our way down, the way that we look at it is we say, okay, whatever number is in row 1, column 1, when I'm doing this process, I'm going to say it's a positive number. Regardless of whatever actually is in the matrix, I'm going to say, well, I'm going to treat that like, a plus. Now, the sign of the number itself does play a role, uh, but bear with me for the time being, and I'll explain a little bit. This will become a little bit more apparent. So this will be a minus and a plus and it alternates all the way through, a minus and a plus, a minus and a plus, a minus and a plus. Okay? So that is essentially going to tell us, well, whatever number is kind of there in that spot, we're either going to add with it or subtract with it, or that's what that array of positive and negatives mean. And let's take a look at that, what it means here. So here's our 3 by 3 matrix. Okay, and again, I don't know why there's no brackets, but you get the idea. Now, again, what it's telling you, it says, well, picking something with a 0 is helpful because multiplying by something by 0 makes it go away. And so that's why it's helpful, because multiplying by 0 is nice, less stuff to do. So we're going to take a look at the very first row where the 0 happens to be. Now, what I'm going to do is I'm going to find the minor of each number in that row. So I'm going to find the minor of the 3, the 1, and the 0 the same way that we just did it. And whatever that minor is, I'm going to multiply it by the 3, the 1, and the 0. And then whatever that is, I'm going to combine them through addition or subtraction. And that's kind of what that array on the right is going to help me do. So let's see how it works. So it's going to kind of give it to us all at once. Okay, so the minor of the 3, again, if you kind of just cross out the row and the column where that 3 is located, what I'm left over with is a 3, 5, and a 2, and a 1. And we get the same thing if we cross out the row and the column where the 1 is located, the row and the column where the 0 is located, and we wind up with those particular numbers, the 2, the 5, the 1, the 1, and then the 2, the 3, the 1, the 2. So again, if you have questions about how those came about, this would be a good thing to write a note to yourself to and come back and see me in class or in tutoring. So I'm not 100% sure where these numbers came from. Okay, but if you're still with me and you want to keep going, let's keep going. All right, so now that we have the minor matrices for the 3, the 1, and the 0, what we're going to do using this number array, we're going to put either a plus sign or a minus sign in front of those numbers to show, well, we're either adding here or subtracting here. Okay, so looking at the first row, we have a plus, a minus, and a plus. So that's why the 3 has a plus sign in front of it, the 1 has a minus sign in front of it, and the 0 has a plus sign in front of it, because that's what corresponds to that plus minus array that I have written over there on the side. Now at this point, we're going to find the actual number that the minor produces. Okay, so if I say, and I'm going to give it a little bit more detail here. If I say, here's the 3, I'm going to say inside here, 3 times 1 minus 5 times 2. Well, 3 times 1 is 3, 5 times 2 is 10, so if I say 3 minus 10, I get a negative 7. And negative 7 times 3 is where the negative 21 comes from. And we're going to do the same thing with the other two minors. 2 times 1 minus 5 times 1 gives me a negative 3. And really, it doesn't matter what the minor gives me on the last one, because the idea is that it just gives me a 0. So 0 times anything is 0, so I don't really care what the minor simplifies to be at the last one. Well, so now if I say negative 21 minus negative 3, that's like 21 minus, or negative 21 plus 3, which is where the negative 18 comes from. So again, let's call this F, just because I haven't used F in a while. So we could say like the determinant of matrix F is negative 18. Now, at this point, what I want to do is I'm going to try and show you a different method, and it's going to eat up a little bit of real estate here, hopefully not too much. So if I have to erase something, unfortunately I will, but you've at least seen it and had an opportunity to copy it down in your notes. At this point, what I would recommend that you do, the matrix that is right here already, copy it down again. And what I'm going to do, I'm going to have no choice. I'm going to back this up a little bit to this point here. Okay, and let me clean up the screen. Go away. All right. So what I'm going to show you here, this is the column rotation method. And this is going to produce the determinant of -18 also, but it's going to be slightly different than using the minors. Now, using the minors is very helpful. In fact, for using the minors is essential in creating something known as a matrix of minors, which is essential if we're going to find out what the inverse of a 3 by 3 matrix is by hand. But that's not the only way to determine the matrix or the determinant of a 3 by 3 matrix. So let me show you what I mean here. The reason why it's called a column rotation is because I'm going to take the first two columns and I'm going to rotate them outside of the matrix on the right side. So the first column is a 3, a 2, and 1. And the second column is a 1, a 3, and a 2. So that's actually the column rotation. Now, this is very similar to the process that we did when we were finding the determinant of a 2 by 2 matrix. In a 2 by 2 matrix, I basically took the diagonal numbers going down from the top left to the bottom right and multiplied those together. And then I took the diagonals from the bottom left to the top right and I multiplied those together. And whatever those were, I subtracted them from each other. Okay, well, this is kind of the same thing, but there's more diagonals that we have to take care of now. And we can't just use it with the one diagonal going down, meaning I can't just use the 3, and the 1 here, and the diagonal going up, the 1, the 3, and the 0, because it just doesn't work. There's not enough information contained in that, and it doesn't produce the same number that it wouldn't produce the same number that we got using the minor method that I just showed you. So this is how I'm going to do it. Okay, I'm not going to have just one diagonal that I'm going to be looking at. I'm going to take a look at 3 sets of diagonals going down, and that is going to kind of give me the the A times D part of a 2 by 2 matrix. Okay, so here what we're going to do is I'm going to kind of put this in its own parentheses, and each diagonal going down gets multiplied together. So the first diagonal, 3 times 1, those 3 numbers get multiplied. And I'm going to add the next diagonal going down, which in this case would be 1, 5, and 1. So those get multiplied together. So 1 times 5 times 1. And then I'm going to add the third row, or the third diagonal, I should say. Those get multiplied together. So 0 times 2 times 2. So all of that is contained in its own parentheses. Now I'm going to subtract the next part. And this is again where I'm going to take the diagonals going in the opposite direction, multiply those together, and also kind of combine them through addition. So let me show you what that means. So the first diagonal from the bottom left corner going up to the right is a 1, a 3, and a 0. The next diagonal would be a 2, a 5, and a 3. And the third diagonal would be a 1, a 2, and a 1. What I'm going to do is I'm going to take those diagonals going up, multiply those together, and multiply and add those together the way I did in the first set of parentheses here and see what we wind up getting. So let's see how it looks. So we're going to say 1 times 3 times 0 plus the next set of diagonals multiplied together, 2 times 5 times 3 plus the third set of diagonals going up multiplied together would be a 1 times 2 times 1. And I'm going to just simplify everything inside of each set of parentheses. So starting at the far left, 3 times 3 times 1 is a 9. 1 times 5 times 1 is a 5. 0 times 2 times 2 is 0. And so we're going to subtract. Now I'm going to simplify the three products of the second parentheses. 1 times 3 times 0 is 0. 2 times 5 times 3 is a 30. And 1 times 2 times 1 is a 2. So just, again, combine your like terms, combine your numbers in the parentheses. 9 plus 5 times 0 is 14. 0 plus 30 plus 2 is 32. And so 14 minus 32 gives me the same determinant, negative 18, that we got using our minors. So now this, again, is called the column rotation method, and it works. That first initial kind of horizontal process that we do right here can take up a fair amount of space on your paper side to side, but if you like it, you're welcome to use it. Now the minors, that process that we did, again, that I'm showing it to you because you have to, you could use that for other things besides just the determinant, but so now we've seen two things, the column rotation method and the minors to determine what I keep saying determine, to figure out the determinant of a 3 by 3 matrix. So whichever method that you prefer, you're welcome to use. Now, the last thing I want to show, and then I'm going to have to just kind of, there we go. Here's the exact same matrix that I just did the last two things on, the exact same matrix. So the point is to show you that you can use any row or column, any horizontal or vertical line essentially in the matrix to get the same determinant. So here, let's try the column. Okay, so looking here, and again, after maybe doing this one, pause the video for the successive ones and try them on your own and see are you getting the same thing. So what I'm going to do here is, okay, well, what would the minors of the 0, the 5, and the 1 in that column be? So I'm going to draw a line through the row that contains the 0 and the column that contains the 0, and whatever's left over would give me my minor matrix. So I would wind up saying 0 and times that minor matrix of 2, 3, 1, and 2. And I would do that for each number in the column, and if I do, I wind up with this. Okay, now again, let me just kind of put it right here as a reminder. The array of positive and negatives that's what tells me what sign to put in front of the 0, the 5, and the 1 when I actually do my addition at some point. So now that I know the minors of each particular number, I would find the determinant of each minor and then multiply it by the number that's in front of it. Okay. So the first thing I'm going to do, looking at the column where the 0, the 5, and the 1 came from, well, the 0 has a plus sign in its spot, the 5 has a minus sign in its spot, and the 1 has a plus sign in its spot. So that's why I put a plus, a minus, and a plus in front of those numbers. Now, even if those numbers were negative, I would still put that plus, the minus, and the plus where they belong, according to that array. And so now I'm going to figure out what the minor is actually equal to as a determinant. And so 2 times 0 minus 3 times 1 doesn't matter because I'm multiplying by 0. It goes away. So the next one, 3 times 2 minus 1 times 1, well, that's 5. 6 minus 1 is 5, and 5 times 5, that's where the 25 comes from, and so on. And when we work it all out, it simplifies to be a negative 18 again. Okay, so here I'm going to first show you what row or column to use, and again, pause the video and try figuring out the minors and make sure that you can get the determinant of negative 18 again, and restart the video when you're done. So here is the row, I'm sorry, not row, here's the column. So at this point, pause the video, try figuring out the minors, and show the determinant is 18, and when you're done, start the video again. Okay, I'm going to assume that you did what I asked you to do. So here, we're going to again kind of look and say, okay, well, what would the minor of the 1 be? Well, I put a line through the row and the column where the 1 is located, and whatever's left over is its minor matrix. So that's the 2, the 5, the 1, and the 1. And I would do that for the 3 and the 2 as well. So there are their respective, minor matrices. Now, if you notice, We don't have a zero to multiply by anymore. That's why it says it's helpful to pick a row or a column that has zeros, because multiplied by zero, hey, it goes away. Poof, good, done. Less work for me. So what sign gets put in front of it? What sign gets put in front of the 1, the 3, and the -2? Well, if you look at the column of that plus minus array and match up the sign with the number, well, the top number is that 1. Well, the top sign in that same column is a negative, and then a positive and then a negative going down. So that's where I'm going to say a minus, a plus, and a minus in between there. Multiply the AD minus BC of each minor matrix and get their particular values and multiply by the number on the outside. Well, 2 times 1 is 2, minus 5 times 1. Well, 2 minus 5 is -3. So I'm going to say -1 times -3, which is, +3, and just so on. Just type it in your calculator as you go, and there you go with -18. So now let's take a look at the last one here. So here, pause the video, find the minors of that particular row, and show that it gives you a -18 when you're done. When you're ready, restart the video. Okay, I'm going to assume that you did what I told you to do and you restarted the video. So now let's take a look here. Okay, so if I cross out the lines, or at least I cover them up to see what the minor matrices are going to be. 1, 0, 2, 1 with the 2, the 3, 0, 1, 1 with the 3, the 3, 1, 1, 2 for the 5. Okay, so what signs get placed in front of it? Well, if I look at that middle row of the plus minus array, I'm going to get a minus, a plus, and a minus. So in front of the 2, I put a minus sign. In front of the 3, I put a plus sign. In front of the 5, I put a negative sign. Figure out the individual determinants, multiply them by the 2, the 3, and the 5 respectively, combine all your numbers to simplify it, and you should get a -18 again. Now here we're changing up the matrix a little bit, so that way it's not, try to give you something different so you know. The last example is just to show you it doesn't really matter what row or column that you pick, you should get the same determinant regardless of what you do. So here's a 3 by 3 matrix, and here, that is the row that I want to use because it has the most zeros in it. Oops, I said 0, so I don't write 0. So minus, plus, minus, plus, minus, plus. There's your number. There's your plus minus array. So at this point, go ahead and pause the video. Try figuring out what the determinant of this matrix is. And when you have it, start the video again. So pause it now and come back when you're done. Okay, so I'm going to assume that you did what I told you to do. So the first thing we want to know, what is the minor of the 0, the 0, and the 7, which really doesn't matter except for the 7, because the minors of the zeros don't really matter because it's just multiplied by 0. So all I really want to know is what is the minor of the 7, okay? So the minor of the 7 is 2, 5, 4, 2. So 2 times 2 minus 5 times 4. 4 minus 20, -16 times the 7 gives me a minor of 112. A determinant, I should say, of 112. And there you go. Okay, so here is a new matrix, and there's no zeros, so the row or column is kind of arbitrary, but we've identified the bottom row to use. So at this point, again, pause the video, figure out what the determinant is. When you're done, start the video again to check how you did. Okay, so now that you've started the video again, let's go ahead and see what we got. So the minors of the 3, the -2, and the 1 are 1, 3, 2, -1 for the 3, 2, 3, -4, -1 for the -2, and 2, 1, -4, 2 for the last number. So what signs go in front of the 3, the -2, and the 1? Well, I'm going to look at that row. Well, that row of my number array has a plus, a minus, and a plus. So I'm going to put a plus, a minus, and a plus in front of those numbers. Okay? And if you notice in the middle, we're basically saying minus -2, which turns it into a +2. Okay, so when you multiply all that stuff through, you're going to get 3 times a -21. Really, you're going to say negative times negative, so that 20 in the middle is like saying +20. And then the 1 times the 8 of the last minor matrix, and you get a determinant of 7. Now here, it should be obvious which one we're going to look at, because the middle row has a whole bunch of zeros. That's the one that we really want to look at. And this one you don't really have to pause the video for, because 0 times 0 times 0 says the determinant of this matrix is 0. And the only other thing that tells you is because the determinant is 0, we would say that this last matrix is a singular matrix, meaning we cannot get an inverse of that last matrix. So this is where we're going to stop for this lesson, where again we're just kind of looking to see how do I figure out the determinant of either a 2 by 2 or a 3 by 3 square matrix. And the 2 by 2 matrix is pretty straightforward. It has the least number of operations to worry about. The determinant of a 3 by 3 matrix is a little bit more complicated, and you could either use the either pick a row and pick a column, and use it particular row or column's minor matrices to figure out what the determinant is, or you could use the column rotation method, whichever one works best for you. At this point, again, any questions or thoughts that you've had that's something that you're not quite sure about, have them written down so that when you come to tutoring or to class, you know what your questions are. You don't have to try and remember them. So, but anyway, thanks again for watching, guys, and we'll see you in class soon.